execute this code if this input as integer is actually not equal to null, so that there is a valid value. And yes, there is, with if statements. Of course, there must be a way for us to only execute certain code if a specific Boolean condition is true. So what we can do is we can say if, and then in parentheses, we actually put the condition, so the actual Boolean value. And if that Boolean value is true, so if input as integer is not equal to null, that's actually a comparison operator that I forgot to cover. This exclamation mark equals operator pretty much just means not equal to. So we have equals, that would mean, okay, input as integer is null. And then the code here in the curly braces would be executed if it's null. But we want to check if it's not null, because then we have a valid value. And if we then take this is even line, cut it out and put it in here, you can see suddenly we don't get this error anymore on this modulo operator. Because that's another feature of Kotlin's null safety mechanism, that if we have such an if condition and we only enter this code here, if the input as integer is actually not null, then Kotlin is smart enough to know, okay, inside of this code, input as integer can't be null. And therefore we can perfectly use it for such a calculation, because the code knows, okay, this is always a valid integer number here. And then we can simply move this print line statement in here. Let's actually capitalize that, and then actually use this is even in here. And if we now run this, there we go, please enter a number. We say 5. Then it says, okay, that's not even. If we now enter an invalid number, like hello, then our code simply finishes. So now it does not print this anymore, because this if condition, these curly braces, that's simply not entered anymore, because that condition evaluated to false, since input as integer was null in this last example. And if there is an if condition, then there also must be a way to do something in the else case. So if this condition is actually false and we want to do something in the other case, then we can do this with an else here. Again, opening curly braces, and then the code here in these curly braces will be executed if this condition is actually false and would not enter this if block. So here we could say something like, dude, enter a valid number. And we could of course also nest these if conditions. So we could also go in here and say, if is even, which is again a Boolean, so we can use this Boolean for our if condition. If is even is true. By the way, many coding beginners do something like this, where they say is even is equal to true. That's redundant, because is even is already a Boolean that is expected here in these parentheses. This way you would just compare whether true is the same as true, which is always true. So don't compare this with true, just pass is even. And then in here we can say the number is even. And we can again have an else condition where we say the number is odd. And then we get rid of this line. So this way we really have a different print line statement depending on whether the number is even or not. So if we run this and we enter a number, we enter 5, then it says the number is odd. So we now have it as a readable language and not just the number, or is the number even, true or false? No, we can really say the number is odd. If we enter an even number, it says the number is even. And if we enter an invalid number, it says, dude, enter a valid number. And by the way, something you can do with Booleans that I also haven't covered yet is you can negate them. Because of course, if you have a certain Boolean and we want to execute code in this example, if that Boolean is not even, so if it's odd, but we've saved the information whether the number is even. Of course, we could do it with this else condition here, which would allow us to print something if it's odd. But let's say we only want to print one case. We only want to print the odd case. So we don't want to print if the number is even. So of course we could remove this, but then we would have this ugly empty if body, which actually doesn't do anything, just in order to be able to have this else condition to print if the number is odd. That's of course not necessary. We can move this in here, remove the else condition, and simply negate this Boolean condition by prepending it with an exclamation mark. So this way, if we run this, then we can enter a 5 and it would print the number is odd. If we enter an even number, it would not print anything because we got rid of the else branch. If you however have an else branch like we did before, then I would always make sure to have the if condition in here non-negated, because it's always easier to understand a non-negated condition than always having to negate it in your head to understand under which condition this branch would be entered. With a simple Boolean, it's easy to understand, but sometimes in the real world, these conditions are not always that easy. A plain Boolean, sometimes you have chain Booleans with logical operators and so on. So I would always try to make sure to negate as little as possible if you use this else branch. The interesting thing about if statements in Kotlin is then we can also use them as an expression. So an expression would, for example, be something like this, something that we can assign to a variable. So what does that mean? We could, for example, go ahead and say val output, and we set that variable equal to if input as integer modulo 2, if that's 0, then we say we open a body and we simply phrase a string here. We say the number is even, and in the else case, we say the number is odd. So this output is now a string. If the input as integer is even, then this string is assigned. And otherwise, this string is assigned. So we could now go ahead and get rid of this if else here and simply say we print this output. And if we run this, enter an even number, it again says the number is even. If we enter an odd number, it says the number is odd. So if you have a certain condition, and if the condition is true, you want to assign one value to a variable, and if the condition is false, you want to assign another value, then you can just use an if-else condition here as well to just assign that to this variable. Of course, this is now a case where you have to have this else block, because if we get rid of it, the code doesn't know, okay, but what if this condition is actually false? What value should I then assign to the variable? The variable, of course, always needs to have a valid value. If this condition is false and you say, okay, in that case, the variable should be null, you would also need to specify that by saying else null. So then if the condition is true, this value would be assigned, and if it's false, null would be assigned. But this would, of course, now mean that the output could be null, and that's why we get this question mark again after the string. So we would need to have all these null checks again, in this case, if we wanted to do something with this output. Here, none of these null checks are actually necessary, because if we pass null to the print line function, then it will simply print null in the console. So that is a valid output also for a null value. Sometimes, however, you also have multiple if conditions and not just an if or an else. In these cases, you can also make use of so-called else if conditions, which simply comes in between, and you can have as many as you want. Well, in this case, it wouldn't make sense to add an else if here as a third condition, because for this input as integer not equal, being not equal to null, there are only two valid scenarios. Either it's null or it's not null. But imagine we want to check whether the input as integer is actually a specific number. For example, here we could say the number is even. If the number is odd, then everything afterwards will be executed. But we could check, okay, if the input as integer is actually less than 10, for example, then we say the number is odd and less than 10. And then we can have an else condition where we say the number is odd and at least 11. So I think you get the idea how this works. If we now enter an even number, it says the number is even because the initial if condition, which is checked first, will be entered. Then if we enter something like 15, it says the number is odd and at least 11. That's correct. And if we enter something like 5, it says the number is odd and less than 10. And as I said, you can have as many of these else if conditions as you want. So you could just go ahead and say you have another one here, and then, oops, the else should be here, and then simply map another condition to some kind of other string.